Hey everybody, this is Alex Merced and welcome to some more talk about Python. And today we're going to be talking about functions. Functions are one of my absolute favorite topics. So let's make a new file. So I'm going to click over here, make a new file, and we're going to call it, we will rename it to functions. Okay, so now what is a function? A function is basically essentially attaching a block of code to a name. And basically what you can do is you can, actually I want to keep that in that first cell, you can run that code anytime for as many times as you want. Okay, I like to think of it as like having a magic spell. So if you ever play like Baldur's Gate 3, you know, Gale can learn spells. And once he learns them, he can reuse them as many times as he wants. Okay, same idea here. Okay, so the way you create a function in Python is you use the def keyword for you're defining a function. So a lot of other languages, they use like func or f or fun. In Python, it's def. Same thing in Ruby. It's def for define a function. So then we give the function a name. So we're going to call it, let's say, my function. And then you're going to put a parentheses here. We'll talk more about that a little bit later on. And then you're going to put a colon because we need to give it a code block, which means, again, we're going to give it an indented code block. And then in here is where you would say, hey, when I use this function, what does this function do? So in this case, we're going to say this function prints basically a bunch of equal signs. And nope, I want to give it one more line. I want to do the same thing again. Okay. Cool. So there's my function. So now if I want to use the function, like once it's defined, okay, I can go, I mean, again, once the indented block of code ends, that means my definition of the function has ended. To use that function, I just do my func and I can invoke it. And I can do this as many times as I want. So I can go my func, over and over again. And then if I run this code block, okay, you see that it does that. Okay, cool. So that is a thing that I can do. I can create pre-programmed blocks of code. Now, which would be more interesting is not that the code block does the same thing every time, but maybe there's some way I can influence it. And that's where this parentheses comes in. Maybe there's something I don't know. Like maybe what I'd like to do is I'd like to print a message right here in the middle between these two lines here. Okay, I would like to print, let's say, a message, which will be stored in a variable called message. But how does it know that this variable message is supposed to be coming from somewhere? What we have to do is we have to declare it here in this parentheses. So when we define the function, we can declare our placeholders, variables for things we don't know yet. Okay, they're called parameters. Okay, so again, that's a parameter. Okay, represents a variable of something that I won't know until I actually use the function. And the way I pass that parameter a value is that when I invoke the function, so again, here I am defining the function. And then here, what I'm doing is I am invoking the function. Okay, aka using the function. Okay, so now what I can do is I can pass it some sort of value, and whatever the first value I pass will go into the first argument. The first thing I pass in those parentheses will then be the value of the first parameter that time the code runs. So in this case, as if I say cheese, bread, wine. Okay, and I go back here just so that it redefines the function. Run this again. Okay. Then run this cell again. And you see on the first run of the code, that one, you see the message is cheese because that's what we passed in here. So this gets passed into here. So that shows up in here. And the second time is that, and the third time it's that. So you could theoretically do all sorts of really cool things with this. Okay, I can create functions that do useful things. Okay, and they can take as many parameters as you want. Okay. So for example, I could say, hey, print, or actually let's create another function called define, print values, we'll call it. And it's going to take two arguments, or it has two parameters, x and y. Okay, and what it's going to do, it's going to first print the value of x is, and then it'll print x. And then it will print the value of y is, okay, y. Okay, cool, and there's our function. Okay, now what I can do is I can use this in a couple different ways. I could just do this by order. So if I were to do this, print values, and I do 4, 5, okay, what I'm doing is like basically the arguments fill parameters in order. So the value of x is 4 because 4 was entered first. So the first argument will go inside the first parameter, and the second argument will go inside the second parameter. But I can also do named arguments in Python, which is something you cannot do in other languages like JavaScript. In other languages, it may work a little bit differently. So in this case, what I can do is I can say, hey, print, and I'm going to say, hey, x equals 4. Actually, let's do y equals 4, and x equals 5. So even though I'm putting the numbers in a different order, okay, I'm putting the numbers in a different order, I'm still assigning this to y explicitly. And let's see what the result is. Okay. Oh, it's print values. Print values. See, it's good to read the errors because I can see like, oh, okay, well, per print, that's not the function I intended to run. Okay. And the value of x is 5, and the value of y is 4. So in this case, it honored my explicit saying, hey, this argument equals this, and this argument equals that. So you can actually name your arguments and then be able to pass them out of order if you know what the argument names are. So that's pretty cool. That can be very powerful. Cool. But functions are just a great way of making portable code to do things that you plan on doing over and over again. Oftentimes, I basically, the way I look at it is if I find myself doing the same task more than once, so if I even see that same 3 lines of code twice in my code, I'm going to write a function and then replace those 2 spots with the function. Okay, that way if I need to update that logic, I only have to update it in one place instead of 2 places. It makes your code more maintainable if you take repeated logic and turn them into functions. Now, there's another way you can write functions called lambdas, which are essentially quick one-line functions. Okay, and basically the way this works is I can save, let's actually, let me just write over here. Okay, let's say, hey, my lambda, or actually we'll call this add, equals a lambda. We use a lambda keyword, and then you just do something like you define your arguments. So in this case, it's going to take 2 arguments, x and y. And then what's going to return is x plus y. Okay, so essentially this is the argument names, and then basically you just do a quick, it does this. These are usually for really quick one-liners, not for like really long complex functions. Okay, and then I should be able to use it. So let me just, oh, well, that's fine. Okay, and then I can just be like add, print, add 2 and 2, and this should return 4, and I get back 4. Okay, so this is going to be really useful when you're working with arrays. Okay, because when you're working, I mean, not with arrays, like, JavaScript habits die hard. When you're working with lists, okay, lists and dictionaries and things like that, because oftentimes particularly with lists, you might use a function called map and filter. Okay, so for example, I may have this array here, or this list. So we'll say my list equals 1, 2, 3, 4, 5. And what I want to do is I want to double the list. I want to take each value and double it. Well, this is a good use for the word map. The map function, what it does, allows you to create a new list of items based on a function that will be applied to each one. Okay, so essentially the way this works is on a new line, we'll say, hey, my new list equals, okay, and then we'll say the map function. And the map function, I'm pretty sure it takes, I always forget whether it takes the function first or, and important lesson, you don't have to remember everything all of the time. Okay, that's why there's resources on the net. And just some advice, maybe it's good to like look up, hey, the syntax of map. The problem is map's a function in like every language. So in this case, you want to be specific in Python. Okay, so that way you can find the exact syntax for it. Okay, so now I find that. Now what I want to do is I want to just find yep, so it's the function first, then the iterable. Okay, I almost did it the other way around. Okay. So then what I want to do is say, hey, the function I want to apply, and this is where a lambda is really handy, because I can just put the lambda in there in line and say, hey, lambda, I expect to take the item. Okay, so my argument is going to be item. And I want to take the item and I want to multiply it by 2. Okay, so there's my function. So it's basically going to take each item and then return that item multiplied by 2. And then the array that I want to, or the list that I want to do this on is my list. Okay, so there's going to be my new list. And then what I'm going to want to do is print the new list so you can see the updated list. As you're going to see in a second that we're not quite out of the woods yet. But so when I do that, notice I don't get the new list. I get this map object. Okay, so what's really happening with the map function is that it returns you the data, but it's wrapped in this map object. The reason being is that Python isn't going to assume what you want is another list. Maybe you do want a list. Maybe you want a set. Maybe you want a tuple. Maybe you want something else. Okay, but you have this iterable map object you can use and pass to anything that would take that iterable object and make something else out of it. So in this case, I want a list. So then I'm going to use that list function, lowercase list. So I'm going to wrap that in there because that's what this is going to do. It's going to pass, I'm passing that map object to the list function. And now that should give me my actual list. And see, now I get that list with all the values doubled. Okay, so what is map doing? It's taking my original list, which is this, and then applying this function to each item. So item times 2, 2, item times 2, 4, item times 2, 6. And this is a great way to apply a transformation to everything that's inside of a list of stuff. Like if you have a list of students and you need to calculate the score for each one, of all their grades, or like what their average grade for the semester is, you can then map over them and then create a new list that has their average scores or something like that. Okay, so that's what map's for. And then filter is the other one this is going to be really good for. So once again, we'll still use my list, but we're going to say what filter does is that it doesn't change the list. It doesn't give you an altered version. What it does is it allows you to literally filter the list and say, hey, I only want the items that match this question. So generally you're going to give it a function, but the function has to return true or false. So you have to use a Boolean expression. Okay, so in this case, we'll say, hey, my filtered list equals filter, same logic. So we pass a lambda. So lambda could be a function. Like I could write a function like I wrote up here using the def keyword, but I'd have to do that separately. And then I would just pass in the name. I would just pass in like print values. I could do that. But again, this lambda is really good for this type of situation. So in this case, I only want the even numbers from my list. So I'll say, hey, item. Okay, and I only want the items where if you modulo them by 2, it's going to end up equaling 0. Okay, so that's my expression. So I'm saying, hey, given each item, return this. And I want you to do that to all the items in my list. Now, once again, we'll take the result of filter and we will print it out. So I'm going to print out my filtered list. And then, boop. Okay, where did I make a mistake there? Oops, 3 equal signs. Again, JavaScript habits die hard. In JavaScript, you have 3 equal signs. Long story. Okay, so let's try that out again. Okay, and see, once again, you get this filter object. Because again, Python is not assuming you just want another list. Okay, so it's like, okay, what do you want me to do with this? Use this to construct the object of your choice. So maybe this time I want a tuple. So I can use the tuple function. Pass the result to the tuple function. And now I should have a tuple with my results, 2 and 4. Okay, so basically the only thing in there are the even numbers, which, yeah, are 2 and 4. Okay, because apply this function, and whenever this function returned true, that item got added to the tuple. Okay, so this is kind of how you use functions a lot. You know, either to do transformations using maps. So maps, again, a great tool for doing transformations, or to filter. Okay, and oftentimes when you're doing a lot of data work, it's a lot of mapping and filtering. Okay, you're mapping an existing list of values to another to get a desired alternative list of values, and then you're trying to query values. So oftentimes you'll see that a lot of these libraries that are used for data, like pandas and polars, will have their own map and filter functions built in to do operations like these. Because again, there you have pandas, which uses NumPy arrays. And correcting myself from a few previous video, you have polars that actually uses Apache arrow arrays. That's why part of the reason why it's faster is written in Rust, and you're using Apache arrow arrays, which if you've watched my video where I went over what Apache arrow is, you'll understand why that would be faster. Okay, so yeah. So we're gonna do a little bit more of the core Python, and probably then we'll start getting into data frames. Specifically, we'll explore with polars. And just doing some sort of operations on data frames using polars and loading up like a Parquet file and things like that. So with that, I'm going to wrap up this video, but I'll see you all soon.